All right, so let's say you're like really trying to up your coding game, right? You're tired of that messy, impossible to untangle code.
Yeah, we've all been there. You want your software to be, cleaner, easier to work with, more maintainable.
Totally. And I've heard about this thing, the law of Demeter, LoD.
Ah, yes.
Yeah.
LoD. It's not some obscure ancient scroll hidden in a temple somewhere.
Right, like it's actually a principle that can like totally change the game when it comes to writing code that's like elegant but also super robust.
You hit the nail on the head. And it all boils down to this idea of reducing coupling.
Okay, reducing coupling, I've definitely heard that term thrown around.
It's a bit of a buzzword, sure, but for good reason. Think of it this way.
Okay, I'm listening.
You've got this massive software project, right? And it's made up of all these different parts, modules, components, whatever you want to call them.
Right, like a well-oiled machine, ideally.
Exactly. But if those parts are too intertwined, too dependent on each other.
It's like that old saying, one bad apple spoils the bunch.
100%. One small change in one part can ripple out and cause chaos in completely unrelated areas.
Okay, yeah, I've definitely been there, felt that pain. So how does LoD come in to, like, save the day?
Think of LoD as like the opposite of that tangled mess.
Okay, I like where this is going.
It's all about setting clear boundaries, defining responsibilities. It's like good urban planning.
Urban planning. I'm intrigued.
You've got your different city services, right? Sanitation, transportation, electricity.
Yeah, the things that keep a city running smoothly.
And ideally, they should be able to function without stepping on each other's toes. LoD brings that principle to your code.
So less spaghetti code, more well-organized city. I like the sound of that.
That's the goal. Now, instead of just talking about it abstractly.
Please, let's get concrete. Give me an example.
All right, imagine this. You're building a music streaming app.
Okay, I can picture it.
And you need to write some code to play a song from a user's playlist.
Pretty standard stuff.
Now, you could write something like user.getPlaylist.getSongIndex.play.
Right. Seems straightforward enough. You're just telling the app to play a specific song, right?
Exactly. But here's the thing. That seemingly innocent line of code is actually a violation of LoD.
Wait, really? Why? What's the issue?
The problem is that the user object, in this case, shouldn't need to know about the internal structure of the playlist object.
I don't think I've ever thought about it that way before.
It's like expecting a customer at a restaurant to go into the kitchen and tell the chef exactly how to prepare their meal.
Okay, that's a hilarious image.
It creates all these unnecessary dependencies between different parts of your code.
So instead of having our poor user rummaging around in the playlist's metaphorical kitchen, what would a more LoD-friendly approach look like?
Much better. A more LoD-friendly approach would be to have the user object simply say, hey, playlist, play this song.
So like user.playsong, playlist name, song name, or something.
Exactly. You got it. The user object doesn't need to know how the playlist is structured internally. It just needs to know what it wants.
Okay, so it's all about keeping those interactions high level, avoiding those deep dives into the internal workings of other objects.
Precisely. It's like each object having its own little zone of responsibility.
And if those zones need to interact, they do it through these well-defined interfaces. No more barging into each other's kitchens.
Now you're getting it. And this ties into a key concept in software design called encapsulation.
Encapsulation. I've heard that term before, but to be honest, it's always seemed a bit, I don't know, abstract.
Well, in essence, encapsulation is all about hiding the internal complexities of an object. It's like you don't need to be a mechanic to drive a car, right?
Right. I can drive a car, but if you asked me to explain how the engine works, I'd be totally lost.
Exactly. You just need to know how to use the steering wheel, the pedals, the gear stick, the interface. You don't need to understand all the inner workings of the engine or the transmission.
So encapsulation is like giving our code at that same level of abstraction. We interact with the steering wheel and pedals without needing to worry about the pistons and spark plugs underneath.
Precisely. And that's what makes LoD so powerful. It helps you enforce that clean separation of concerns.
So we've talked about how LoD helps with this whole decoupling thing and encapsulation.
Yeah.
But are there any other major benefits our listeners should know about?
Oh, absolutely. And one of the big ones is modular design.
Modular design. Okay, break that down for me.
Think of it like a film set.
Okay.
You've got your different teams, right? Lighting, sound, costumes, makeup.
Yeah, and they all have their own specific jobs to do.
Right. Each team has its own expertise, its own responsibilities. And crucially, They don't need to understand the intricacies of what every other team is doing to do their jobs well.
That's a great analogy. And I'm guessing that kind of compartmentalization makes it much easier to manage large, complex projects.
Exactly. If the lighting team needs to change something, it shouldn't require a complete overhaul of everyone else's work, and LoD helps you achieve that same level of modularity in your code.
So instead of having one giant tangled mess, we end up with these neat, self-contained modules that are easier to understand, easier to maintain, and less likely to break when we make changes.
You got it. It's all about managing complexity.
This is making a lot of sense. But isn't modularity just about, keeping things organized? Does it actually have a practical impact on, the quality of our code or how easy it is to work with?
Absolutely. For one thing, modular code is much easier to test.
Oh, interesting. Tell me more about that.
Think about it. When you've got these nice self-contained modules, it's way easier to write targeted tests. You don't have to set up these crazy scenarios with a million moving parts, just to test one little function.
So it's kind of like instead of having to test the entire car every time you tighten a bolt.
Yeah, exactly.
You can just focus on the engine or the wheels or whatever you need to without worrying about the rest of it.
100%. It's way more efficient, less error prone. You can be confident that when you change something, you're not accidentally breaking something else in the process.
Okay, yeah, that makes sense. And speaking of keeping things separate, remember earlier how we were talking about how LoD can be used in different programming paradigms?
Oh, yeah, we were diving into that whole world.
Right, like object-oriented programming versus functional programming.
And how LoD can be applied in both.
Yeah. And I have to say, that blew my mind a little bit. It's LoD transcends those specific languages or styles. It's all about these fundamental principles of good design that can be applied anywhere.
You got it. It's amazing how those principles can manifest in different ways depending on the paradigm.
Right. We talked about how LoD works in an object-oriented context with that music app example.
Yeah, we were looking at how to keep those object interactions nice and tidy.
Right. No more of those train wreck chains of calls where one object is reaching deep into the guts of another. But now I'm curious, how does this whole LoD thing work in the world of functional programming?
Yes, the functional realm. Well, some listeners might be thinking, wait a minute, there are no objects in functional programming, right?
Yeah, that's true. So how does LoD even apply? To be honest, functional programming has always felt a bit mysterious to me.
I get it. It can seem like a different universe. But at its core, functional programming is all about using functions to accomplish tasks.
Okay, functions. I know what those are.
But think of them more like mathematical functions. They take some input, do their thing, and produce an output, ideally without any side effects.
Side effects?
Meaning they don't, change anything outside of their own little scope.
Okay, so a pure function is a mathematical equation. You plug in some numbers, it crunches them, and gives you the result. No messing around with anything else.
Exactly. That's the idea. And this is where LoD comes into play in the functional world.
Okay, I see where you're going with this.
Even though we're not dealing with objects anymore, the core principle is the same. We still want to avoid creating unnecessary dependencies between different parts of our code.
So each function should be its own little self-contained unit.
Right.
It can interact with the data it's given directly, but no reaching into some global data store or messing around with variables it shouldn't be touching.
Exactly. Imagine you're building, let's say, an e-commerce platform.
Okay, I can picture that. Online shopping, everybody's doing it these days.
And you've got this function that calculates the total price of all the items in a user's shopping cart.
Pretty standard e-commerce stuff.
Now, following LoD, that function should only operate on the data that's given to it directly, like the items in the cart and their prices.
Okay, that makes sense. It should stick to its lane.
Right. It shouldn't be reaching out to an external API to fetch shipping costs.
Right, even if it might seem convenient to just grab that information right there.
Exactly. Or it shouldn't be trying to update the user's order history or anything like that.
So even though those actions are related to calculating the total price in a way, they should be handled by other dedicated functions.
Precisely. It keeps your code clean, modular, and much easier to reason about.
So whether we're talking about objects or functions, LoD is all about that same idea. Clear boundaries, well-defined responsibilities, no unnecessary entanglements.
Exactly. It's like having a well-organized workshop where each tool has its specific purpose.
And they don't interfere with each other. I love that.
And when your code is well-organized, it's not just like aesthetically pleasing, it's also less prone to errors. And it's way easier to maintain in the long run.
That's huge. Because who wants to be stuck maintaining a tangled mess of code? It's like LoD is bringing that Marie Kondo philosophy to our code, right? Tidying up, getting rid of what doesn't spark joy, keeping only what's essential.
I love that analogy. And speaking of essential, let's talk a bit about those gotcha moments when you're trying to apply LoD in the real world.
Gotcha moments. Okay, now you've got my attention.
So I'm sure our listeners are like super eager to go forth and write beautiful LoD compliant code.
Of course. Who wouldn't want that?
But is LoD, one of those always follow no exceptions kind of rules?
That's a good question. Like, are there ever situations where it might actually make sense to, I don't know, bend the rules a little bit?
Well, in a perfect world, maybe not. But remember, real-world software development is often about navigating complexities, finding those like practical compromises.
So are you saying there might be times when, a little bit of LoD deviation might be understandable?
Let's say you're working on a project, right? And the deadline is like yesterday.
Okay, yeah, been there.
And strictly following LoD would mean adding a ton of complexity to your code.
Or like delaying the release by a week.
Exactly. In those situations, a minor, well-documented deviation from LoD might be the more pragmatic choice.
Okay, so it's not always black and white. It's more about like finding that balance between clean design and those real-world constraints.
Precisely. It's like think of LoD as a roadmap,
Okay, I like that. A roadmap for our code.
It guides you toward cleaner, more maintainable software. But sometimes, you might encounter those unexpected detours. Or maybe you find a shortcut that, while not like perfectly ideal, helps you reach your destination on time.
So it's not about blindly following rules. It's about understanding the why behind those rules.
100%.
And then like making those informed decisions based on the context of your project.
And that's what separates the, good developers from the truly great ones. It's that ability to apply these principles thoughtfully, to recognize like both their strengths and their limitations.
That makes a lot of sense. So for our listeners who are now like fired up about LoD and ready to put it into practice.
Ready to declutter their code.
Exactly. What's one like key takeaway, one golden nugget of wisdom that they should keep in mind?
Here it is. Write this down. Every time you're writing code, ask yourself this question. Does this part of my code really need to know about that other part?
Or am I like creating an unnecessary connection here?
Yes. Because chances are you probably don't need that connection. And breaking those unnecessary links is at the heart of LoD.
It's such a simple question, but I can see how it could be incredibly powerful.
It's like a superpower for writing cleaner code.
So to our listeners, as you embark on your like LoD-inspired coding adventures, remember, it's not about like achieving the state of perfect, flawless code.
It's a journey.
It's about writing code that is thoughtfully structured, easy to understand, and dare I say, a joy to work with.
And you know what? Sometimes that means getting a little creative, thinking outside the purely by-the-book box.
Well said. Embrace the principles, stay curious, keep exploring, and most importantly, have fun out there.